I can interpret a residual plot. All right, Chrissy collected data relating a person's age to the number of hours of sleep the person gets each night. After graphing the data, she wrote a linear equation to model her data with A representing a person's age along the x-axis. Okay, so we're going to put age here. And S representing the number of hours of sleep. So hours of sleep. What would a negative residual mean in this context? Be clear and complete. Okay, so let's just draw a line. Doesn't matter if it's got a positive or negative slope, honestly. So let's say that this is our linear model. Okay, a negative residual means that the data point is below the line. So what that means is at this age, you would expect someone to be getting this amount of sleep, but a negative residual means that they're not getting that much sleep. Okay, so what would a negative residual mean? That for a specific age, okay, this person is getting less sleep than the model predicts. That's it. And if it was above the line, we'd be getting more sleep than the model predicts. All right, for each residual plot below, describe what you know about the model used with its scatter plot to produce the residual plot below. Be clear and complete. Okay. Well, first of all, there is a general shape of this residual plot, and it's a curve. So what do I know? That a curved model would be a better fit. Curved model will be a better fit. All right, there is definitely a general trend that's happening there. Here, honestly, I'm going to tell you B and C. This was an example that was out of the textbook, and I'm not super happy with either of these because there is no scale. We don't know the magnitude of the spread. All we know is that it's fairly evenly dispersed above and below the x-axis. So I would say that this is a good linear model. Okay, I'm assuming that this is a very tight spread, but we don't really know because there's no scale. And here, I really can't make a decision. I mean, if I assume that these have the same scale along the y-axis, I guess I could say that that it seems to be a linear model, but there is lots of spread and variability in the data, but I would probably never give you a problem like this on an assessment with no scale. Okay, so I would say you can't really tell, but the spread of the data, it seems like a wide spread of variability, but I'm just going to hold judgment on this. Okay, but because it's got an even amount above and below, and there's no real trend, it does appear to be linear. Okay, but again, can't tell because there's no scale. All right.